Josh, you asked me how I bring math to life for students. I just wanted to share that I am constantly engaging kids in the strategies that they use to come up with answers. And I ask them to reevaluate. Is it true? Is it real? Is it right? What are other strategies you can use? I find that this really brings life into my day.
That's great, Doug. Thank you for sharing.
You're welcome.
Every opportunity to provide students with a teachable moment is an opportunity for learning. So thank you. All right, everybody. Thank you for joining me this morning. As impromptu as it may have been, some of you, I got emails from last night that were like, "What meeting?" And I was like, "Well, the meeting that's on my calendar." And then everybody was like, "What meeting?" So thank you for following all the email exchanges last night. And I apologize if it didn't get sent out correctly the first time. So I'm going to start off our meeting by sharing with everybody our last meeting for this current 21 part of the year is going to be December 2nd, Thursday, December 2nd at 8 o'clock. So just under a month from now, because of Thanksgiving, we're going to break that up. So right after Thanksgiving break, we'll meet back up and we will have an opportunity to do some breakout rooms. Today, we're going to be all together as I provide you with some information, have some discussions and conversations together centered around math conversations and how we can spark that discussion even more in our classroom. So thank you for everybody who's done the check-in so far. How do you encourage mathematical conversations in your classroom? Does anybody want to share out? I saw some people shared about their number routines or their math routines in the morning or math conversations in the afternoon. Please feel free to share as we sort of spark our discussion here. Whenever the spirit of coffee moves you.
Recently, Mr. Enders attended our field trip and he took a lot of wonderful pictures of what we saw, and the students are really excited and focused. We've been following up with those slides in the morning, different pictures he took of numbers and letters and shapes on our field trip. So it's kind of an exciting way to kind of follow up with what we saw, and just brings my math to real life.
That's awesome. Making those connections to previous experiences is awesome. Anybody else like to share? All right, so a lot of the comments in the comment section are similar. We have a lot of like number routines. We have any time that we can make connections to real world situations throughout the day. We have videos that we can spark discussions with. Anytime that we can use math vocabulary, that's fantastic. Thank you for sharing. Is imperative to the success in their future careers in mathematics, whether that is direct or indirect. So for today, we're going to be focusing on the phrase sort of letting kids talk, but having taken a different approach to how we question centered around mathematics. So just by tweaking maybe one or two words, we can entirely change the discussion that's centered around a specific standard. So I'll go through some of those examples here. I'm going to give you some strategies, some tips. But first, let's talk about our CPO and our agenda for today. CPO, so we are creating and implementing a brand new math curriculum, and this meeting is designed to facilitate the continued refinement of that program. So we're always looking for recommendations, ways in which we can improve the program, and we're continuing to write the program as we speak. So any way that we can enhance the math content and connect those to real world examples or situations is what we're doing. The purpose of our meeting today is to dive deeper into math conversations and focus on math discourse. So how we can phrase questions and how we can spark discussions within our students and within our classroom. And then the outcome is that you'll have practical knowledge, not just this philosophical knowledge of what conversations are and what they mean, but rather what can I do immediately in my classroom, even starting today? How can I reframe some of my questions and start these discussions within my small groups or individually with my students? Outline for today, we have a check-in, which we already did. We have a sharing session by Nicole, and we are going to then go into our math discourse sort of chat this morning. So taking things away, let's flip it over to Nicole Curcio as she shares some of the ways that she was able to adapt what she was doing in the classroom and enhance what she was doing with this new math curriculum. Nicole?
So I made the mistake of saying that I did something in my room and everybody thought it sounded awesome. So now I get to share about that. Our PBL for first grade for first marking period was based on farming. This incredible slideshow was made for us. And so I started off the week showing the slideshow, and the kids were able to learn about a farm, watch a video about a farm, and they were super engaged. And as I continued through the slideshow, I realized that the week was going to end with them answering questions with math involving adding and subtracting to 20, just based on the different farms. And I was like, oh, I kind of feel like my kids are really engaged in this right now. I want to take this to like another level. And so I decided to create a farmer's market in my classroom. So the first 2 days we learned about the different types of farms, and then my kids each selected one of the 5 farms to run. And so there's like a dairy farm, a corn farm, a pumpkin patch, a sunflower farm, and something else. And so they each designed posters and created 3 items that they were going to sell at their farm. Like the sunflower farm sold sunflower seeds, sunflowers, and sun butter, because that's always a topic of conversation at lunchtime when there's sun butter, not peanut butter. What we did is they like created posters, and then we set up their desks to almost kind of look like farm stands. And then to practice the exchange process, not money, because we are not ready to do that yet. Each item was worth $1. And so I gave them each $10, and they walked around the room and they purchased items from each other, using that, just kind of like practicing that exchange. Like, I'm going to give you $1 and you're going to give me an object. And as they did that, they tallied the items they sold. So at the end, we gathered back together and they like counted their money, and they looked to see, did I receive the amount of money I was supposed to for the items I sold? Did I calculate that correctly? We also looked at what items did I buy, and we made math equations with the items that we bought. And then we went back and also made math equations with the items that we sold. So they were still doing the adding and subtracting within 20, but I wanted it to feel a little bit more like real world skill. And so if they were actually running a shop or a farm and what that would look like. And then we had the discussion of what items did we sell more of or less of, and how would that affect us the next time we opened up our farm show, like our stands, like what would we want to have more of at our market or less of at our market based off of what sold, or how could we maybe adapt like the posters or the advertisements or the way we were talking to our customers to like try to like sell more of the items that might not have been as popular. Like cornbread did not sell well, but popcorn did. So what can we do to make cornbread a higher seller next time, something like that. So it was really informative for the kids, and they had a lot of fun. We really enjoyed it. So it was a cool like experience that I did. It knocked out my whole math block for the whole week, but we had a lot of fun with it.
Awesome. Thank you for sharing, Nicole. And hopefully I'm going to put you on the spot here. But if anybody has any questions for Nicole, just for the sort of the good of the order, maybe not lesson specific things, you can talk to Nicole afterwards if you want to grab that lesson from her, or share any more details there. But any general questions that we have for her, I thought it was an awesome opportunity. You hit on a ton of like real world situations that those are transferable skills that they can do moving forward. All right. Okay. Thanks, Nicole. I appreciate it. Thanks for sharing this morning. I sort of put her on the spot the other week, and I was like, hey, this sounds awesome. Can you share with everybody the next time we meet? And she said, yes, absolutely. So this is great. And this is the type of stuff that we're encouraging you to have conversations on your own. And I know that within your building, it can be easier when you're working with the rest of your team to have these discussions of what went well, what you can do better, if you have an idea, you bounce it off of each other. And what's good about us meeting, and now a little bit less frequently, is that we bring all these ideas back to the table for everybody to benefit from. So anytime that we have that, if you want to like just jot those things down, if you have ideas moving forward, and bring those to the next meeting. So on December 2nd, we'll have breakout sessions for the individual grade levels for you to share out some of those ideas that you have floating on and around your brain. So thanks for sharing again, Nicole. All right, so let's talk about letting kids talk and why Math Discourse encourages deeper connections with students and also with the content that we're actually teaching. So I want to say by definition, a conglomerate of definitions that I was able to piece together is mathematical discourse is more than just simply talking about math, because we can talk all day about any one of our subjects, but if the kids aren't engaged or aren't invested into that conversation, then how much is really landing on them? And then it's more about a set of tools and strategies and practices that makes the learners and teachers thinking visible. I want you to think about that statement right there. How do you make thinking visible for students, or bring it to bring it to fruition for them to textualize what they're doing? And that is really what math discourse is all about. It's more than just talking about the math. It's talking using math to solve bigger problems that are going on. So how learners talk about math reflects part of what they understand. It's not the whole deal, but if a student is able to come up to you and share exactly how they arrived at a solution, you know that they understand that concept. A lot of times our formative interactions with our students are oftentimes more valuable than even that summative data that we collect. So how learners talk about math reflects part of what they understand. And Vygotsky said it well, was that words are tools for building concepts and serve as our social means of thought. Without vocabulary to question, describe, and debate, our thoughts remain in the shadows. How many times maybe have you worked with a student who just can't articulate what their question is? Or they say, I don't get it. And then you ask, well, what is it? And they're like, I don't know any of it. And so without one, math vocabulary, which I know for a fact that we teach in those number routines, and also that sort of question and answers situation where you're building not only the conversation centered around mathematics, but also the confidence in the student to be able to verbalize what their questions are. Those two pieces together go hand in hand when we're talking about math discourse and how they can arrive at solutions. So words are the tools and how we socially interact with one another. So if we're not able to articulate what our solution is or what our problem is, then we're sort of at a standstill. So how can we facilitate that? And that's where there's a book that's called Classroom Discussions Using Math Talk to Help Students Learn. I just recently was able to pick this up and read through it from National Council of Teachers of Mathematics. If you would like that copy, I have one copy. I can share it with you. And I would love to have more discussions about it, but it's a great resource from Nancy Anderson. And I'm going to sort of take some of the big key takeaways, which are ways in which we can empower mathematical thinkers through the conversations that we have. So talking and thinking together can help all students understand math better. Hopefully that's a phrase that we can agree upon. So talking and thinking together can help all students understand math better. If we, and I say we because I was a former math teacher, still a math teacher at heart. If I would get up and share and show a student how to solve a problem, and then don't go any further or don't question them on the process or the means at which I got to that solution, then it's all at moot point because I don't know if they know what's going on without having a conversation. So talking and thinking together can help all students understand math much better. It is necessary for more than one person to solve challenging problems. So sometimes in math, it's easy for us to call on a student, one who raises their hand all the time, or one that we know in the back of our mind knows the answer. So someone that we can rely on. That's like a sort of a safety net that we can throw over at any time. So Johnny or Sally, sorry, there's the two like culturally white names as I can think of right there. My apologies there. But anyway, we throw those questions to those students because we know that they have we know that they have the answers. But the struggle is part of the discussion. So how a student arrives at the situation or arrives at the solution is almost more important than the solution itself. Show you how we can change some of those question techniques that we have to spark that challenge of creativity. There is a great deal to be learned from listening to how others think. And this is more than just a math skill. And I hope, again, we can agree on this, is that it's important for us to understand and put ourselves in the shoes of other people. Because how I solve a problem is maybe drastically different than how somebody else solves a problem. I know that for myself, for years in math, I would tell my students, hey, I'm going to show you one way to do this problem. There are other ways of doing it, but this is just the way that I found that works for me. I would have students who come up to me and say, Mr. Korb, does this work? We'd explore it. As long as it worked all the time, by all means, go for it. They have a different way of thinking. Some students are visual learners. Some students are auditory learners, kinesthetic learners. We know the different modalities of which we can teach meet different students. So our conversations aren't that much different. So there is a great deal to be learned from listening to how others think, because it also expands how you think as well. Talking about your thinking helps you clarify your own thoughts. Sometimes when I can't articulate something, or if I can't think about a solution to a problem, I'll talk it out with one of my colleagues, or I'll talk it out with my wife or my kids at home. We'll try and solve a problem together. Just verbalizing what we're thinking will sometimes unlock those solutions for us as well. When talking about mathematics, you can practice using important math vocabulary. So if a student, think about your sight words. If a student doesn't use a sight word or doesn't look at a sight word, are they going to learn a sight word? No, they have to use it in their regular vocabulary if they really want to master and identify with that content or identify with that word. So same thing goes with math. If we're talking about like sides of a triangle or angles of a square or place value, digits, if we're not using that math vocabulary with them to identify specific parts of math, we're missing out on a great opportunity for them to connect those thoughts even deeper. So using math vocabulary is really important, especially at younger grades, because that stems the whole way through math. You know how math scaffolds itself already. And if you don't understand what like maybe a numerator and denominator are, you can't do anything more with fractions unless you understand what those pieces are. So talking about math vocabulary is important. You can learn a great deal about what it takes to understand the ideas of others. It took me a couple times to read this statement to understand what it actually meant. You can learn a great deal about what it takes to understand the ideas of others. This is all about being open to other people's ideas and open to the thinking of other people, which is a life skill, especially in the day and age that we're in. Oftentimes we find ourselves, we're locked into our own train of thought and we miss things. We got our blinders on. And I say we just collectively, but in this case, we're talking about in specifically math. If we get locked in on and laser focused on one way to do something, we're blocking out all the other possibilities that might stem to greater things. So those were sort of the key takeaways that I took from that book. There are two techniques that I'd like you to try, maybe. And a lot of you have already shared that you are trying these things. So I'd encourage you just two small little things that you can do to really drastically change the conversation centered around math in your classroom. One is a subtle change to question phrasing. And this is this can be the smallest thing in the world, but it leads to the greatest conversations because we're changing maybe one or two words of how we phrase questions. And then direct conversation starters if you want to actively promote these deeper conversations in class. And I have a ton of resources at the end here for you too. First, let's talk about subtle changes. So looking at comparing and contrasting two question types. So there's a triangle on the screen. Question one, how many sides does a triangle have? Okay, everybody with their fingers, how many sides does a triangle have? Yeah, hey, good job. All right, that's the end of our conversation. That's it. Okay, that was the answer I was looking for. That's the answer I got. However, how many, now I know that all of you know it has three sides, but how many times or how confident are we that our entire class really understands what you're thinking or really understands the answer? They just throw out a number. I've ran into this with my own son where he'll just spit out random numbers until he hits one that's right. Like 4, 8, 23, 8, 14, fish. So like any of those answers may be the right one. So we want to actually tackle what's the root of this situation. So let's rephrase the question. Let's say, explain how a triangle is different from other polygons, or say that they're not ready for that polygon word. Explain how a triangle is different from a rectangle. Okay. Now the conversation has room to grow. We have an opportunity for students to bring up what has a rectangle has 4 sides, a triangle has 3 sides. Do we still get the answer that we want? Did we still get that 3? Yeah, absolutely. But look at all the other context that we got with it. We also related it back to rectangles. We also were able to compare it to something else. Maybe a student says, oh, well, it has 3 corners or it has 3 angles. Then it spurs into a whole nother conversation. So what's nice is that if we allow it for room to grow, we allow thought processes to form centered around this just simple question change of how many sides does a triangle have, shifting that to explain how a triangle is different from a rectangle. That's one question. Here's another question. I wanted to try and hit a couple different grade levels here. So compare and contrast the following questions. All right. What is 353 rounded to the nearest 100? Okay. Somebody in the comments, go ahead and throw the answer. What's 353 rounded to the nearest 100? Don't worry, this will not be on your report card. Anyone? All right, there we go. All right, 400. Great. Everybody was like nervous. Like, I know it's 400, but is it 400? Right? No. So, yeah, 400 is the correct answer, but that's our conversation. That's where it ends. What if we said, what are all the numbers that round to 400? Now a couple students might say, oh, well, 356 or 394. Yeah, there you go, Mark. Or like they can throw out any other number. But some student might say, well, any number greater than 350, right? So that, to me, shows me that they really, really understand, because they could have just thrown out the number 4 or 400. Now, yes, that would have blanketed a bunch of students, but if we really want to get to the having conversations around it, framing our questions a little bit differently gets us there. All right, one more. So here's again a subtle change. What is the denominator of this fraction? Show me with your hands or in the comments. We got a 4. Great, thank you very much. All right, looking at this fraction, what can you tell me about the relationship between the numerator and denominator? Now, your students might not be ready for all of that verbiage in one section. So you could say, okay, what can you tell me about the top and the bottom of this fraction? Okay, and then you start having conversations and you start sharing that information of denominators on the bottom. And then you can say, okay, well, what does that mean? Well, that's the whole. Those are the total number of parts that form the whole. And then you can go into, okay, well, here's the numerator. So again, it just opens up the conversation rather than just locking us into one solution. We're opening it up to a greater discourse between our students. All right, so those are subtle changes to question phrasing. The second thing I want to share with you is 100 questions to jumpstart your math discourse. And these are as easy as saying, okay, somebody gives an answer, say that they share 394. Then you follow up that question and you say, okay, do we agree? Now, a lot of us do this naturally, but here are some ways that we can direct our conversation a little bit more to get deeper into the roots of this math conversation. So if you are in this presentation, and I'll drop it in the comments too, I'm going to go ahead and copy the link, and I'm going to throw it in the chat. This is 100 questions that promote mathematical discourse. I want you to just take 2 or 3 minutes, take a look at all of the questions there. Look for 2 things. One, do you already use some of the language in the classroom, which I'm sure a lot of you already do? And then are there any question types or question styles that jump out at you? And these are all mapped to the mathematical practices that I've referenced before, all of those like 8 mathematical practices. So it's really neat how these questions are broken up. So 2 or 3 minutes, go ahead and you can click either on the link in the chat or the link on the slide, and it'll take you to a new window. 2 or 3 minutes, go ahead and look at the questions. All right. So let's wrap things up here by just anybody want to share out anything that sort of stood out to you, anything that you use that's maybe like a go-to phrase. I know that I looked in here and I might have seen a couple catchphrases from when I taught high school math that I would use sort of all the time interchangeably. But are there any ones that stood out to you that you'd like to use moving forward that you hadn't really thought about or hadn't incorporated into your regular conversations with your students?
On the last page, I like the orange box of questions for helping students persevere. Like, what have you tried? Getting them to explain, because a lot of times they're just like, how do I do this? How do I do that? So I like that orange one.
Awesome. Yeah, that was one of my favorites too, because I like give me another related problem. And then also, how would you explain what you know right now? So again, trying to contextualize what they know at that moment and verbally share it out. So thank you. Anybody else?
I think what would happen if, I think we're doing addition with regrouping, and you saying like, what would happen if we would write, if there's 15 in the ones, what would our number look like? Like looking at that wrong, like if they get it right, well, let's look at it, not just that you got it right, but what would you do if you got it wrong? What would it look like? Just
Awesome.
to see that difference.
Yeah, again, extending that conversation beyond just right answers is great.
And I know this is easier said than done. I've heard some of my math teachers, some of the older grade levels ask questions like, does that make sense? Now, I know that's hard to ask probably in like a kindergarten classroom, but, kids are doing a subtraction problem, yet the solution is greater than the starting number, right? And so being able to ask kids like, take a guess. Does this number get close to that guess? I really like that kind of questioning for kids to kind of, again, rationalize so that they're conceptually understanding what in the world they're doing. I'm taking away, so my final answer shouldn't be greater.
I also do, how confident are you in your answer? Sometimes, like I'll just say, and I'm always joking, but I'll say, do you want to bet your entire recess? I do that like very sometimes. And then it makes them think, well, am I right or am I wrong? And I want them to feel like, okay, is it your answer? Is that your answer? And I don't mean like I'm going to take the recess away or we're going to have to do another problem or something like that. But I want them to be confident, not waiting for me to tell them yes or no. I want them to say yes or no.
Yeah, and I like to the question that really stood out to me was the one where it says, I hear your question. Let's go ahead and ask the rest of the class. So getting everybody involved in trying to solve that question or solve that problem, I think is powerful, because you as a teacher, obviously, the answer. You know how to get to that solution. You could walk them through. But sometimes hearing it from a peer means so much more to students. So having that opportunity to share out is great. All right. Since this meeting was scheduled and unscheduled and rescheduled again, I want to value your time. So we're going to wrap things up. So some other resources that are here, if you want to see sort of a full-length case study, this is over the course of like 163 days of incorporating math discourse like strategically in a classroom. There's a really cool interactive course and case study that's called Inside Mathematics, and then it's engaging in mathematical discourse. And it's a second grade teacher, but there is an entire course with videos of like her classroom, of resources that she's used, but it's really comprehensive, and it walks through the process of day one, the whole way up to day 163 or wherever it stopped, of how the conversations grew by taking these strategic steps. Also, a couple other like good reads. We have this Talking Math, how to encourage or engage students in mathematical discourse. And then it's also important to help your students. And this goes back to our SOPs and our classroom code. How do we listen and speak in our classroom? And how do we articulate solutions or articulate our questions? So these are just some speaking and listening checklist. If you click on it, it's a PDF. If you'd like to incorporate that, you can. It was something that I came across as I was looking into math discourse a little bit more. So for our checkout, in the chat, please share your committed action to promote mathematical discourse in your classroom, whether that's continuing a lot of what you shared already, that you already do in your classroom, or are there new strategies that you're going to incorporate moving forward? Once you have checked out, there is just a disclaimer there once again that the next meeting is December 2nd, and we are going to be breaking out into those individual grade level meetings. So thanks for joining today. As soon as you check out in the chat, you're free to go. Thank you.